It now gives me great pleasure to introduce our next speaker. It is Dr. Ian Gardner, and he's an Australian medical specialist with more than 35 years global experience in environmental, occupational and public health medicine. His current major appointment is as Principal Medical Advisor for the Department of Veterans Affairs in Canberra, a position he's held since 2015. From 2001 to 2015, Ian was Defence's Senior Physician in Occupational and Environmental Medicine at the Defence Centre for Occupational Health and Safety, Canberra. Prior to this appointment, Ian has worked for IBM Asia Pacific, IBM Australia, ICI Australia and AIOH of Australia. He has significant senior management and consulting experience in both the public and private sectors and holds a number of part-time advisory positions in occupational and environmental medicine. Ian has degrees in medicine and surgery, as well as a master's degree in public health and professional fellowships from Australia, UK and the USA. He's held academic appointments as adjunct professor in occupational and environmental medicine at the University of Queensland and has also been a visiting professor at the National University of Singapore and the Chinese University of Hong Kong. Ian has twice been elected as president of the Australian Faculty of Occupational and Environmental Medicine and is a joint editor of the textbook International Occupational and Environmental Medicine. Ian is a fellow of AFOM, the Faculty of Environmental and Occupational Medicine, a fellow of the Australian College of Occupational and Environmental Medicine, a fellow of the Royal Society of Medicine and a member of the International Commission on Occupational Health. And in 2013, he was awarded the College Medal by the Royal Australian College of Physicians. So, Ian is going to talk to us today on green testicles and other stories, which sounds very interesting, occupational hygiene and occupational medicine working together. So please join me in welcoming Ian Gardner.
Well, good morning, ladies and gentlemen. Can you hear me okay at the back? Thank you. My job is to wake you up after a very wonderful evening, and I thank the organisers and the committee for the opportunity to talk to my occupational hygiene colleagues. I thank Simon, wherever he is, Simon Warland, in particular. All right, hi Simon. We had a chat and he said, well, you've got to make sure it's interesting. I said, well, I'm going to subtitle it Green Testicles and Other Stories. So, I want to basically use this 30 minutes, I've got a race to get a plane, to focus on the last 40 years that I've spent in occupational medicine and some of the outstanding industrial hygiene colleagues who I've come across in my work. And these are they. Some of you would know these names. Mike Leroy was the first fellow I ever came across when I was working at AIOH in Western Australia at Pinjarra, and of course he was a mining engineer who was studying under the aegis of Barry Chesson, who I understand is not here at this conference, but most of you would know Barry. Secondly, Gersh Major and Alan Rogers, Alan is here. And I'll talk a little bit about Vlad Vasak and of course Gary Gately. Where's Gary? There he is, with a camera, etc. Chris Norden, who most of you would not know, he's a US industrial hygienist, excuse me, who had a lot to do with when I was in Tokyo and IBM Asia Pacific in Japan for many years. And then finally, Wally Mazurek, who was a DSTO, Defence Science and Technology Organisation scientist down in Melbourne. He wouldn't have regarded himself as an industrial hygienist, but in fact he was. And of course Martin Jennings, my long-term colleague at Defence, with whom I've worked very closely for all of his 10 years that he was there. So let's just jump first of all into the green testicle story. If you want to get men's attention in the occupational health and safety, all you've got to do is threaten their manhood or their testicles or both. And this is a great story. I was working in my first industrial occupational medicine job at AIOH at Pinjarra in Western Australia, only from 1980 to 82. It was occupational health heaven, not for the workers but for the professionals. And in particular, this issue about the green testicles arose because of a cleaning program where every couple of years the company would shut down its on-base power station, which was a medium-sized 90 megawatt power station to provide backup energy for the alumina works at Pinjarra. And basically it was both gas and oil fired. At that time oil was cheaper, but gas was cleaner. And this was the descaling program where they get inside the combustion chambers and clean it out using air-powered tools was a horrible job. The respiratory protection was good, but the rest of the personal protection was not. And it was very hard, hot, physical, dangerous and dirty work. One of the interesting things was that I said the respiratory protection is good, but the rest of the body protection wasn't, because it was too hot to wear much in the way of protection. And this meant that people sweated like pigs and they got covered in this dust, this refractory dust. And I knew nothing about refractory dust. I was only 2 years into my OCMed career at that stage. But what happened one day, I was in the medical centre there, and the foreman came racing in with 5 blokes in tow and says, Doc, you've got to see this. And these fellas stood up there, dropped their tweeds, and here were these green testicles. There was nothing in my medical training that had ever prepared me for this. And that's why I say there are no pictures. They'd be banned if I'd taken them. But to cut a long story short, in combination with those 2 industrial hygienists, in particular Mike Leroy and to a smaller extent Barry, we undertook some investigations as to what could be causing this outbreak of green testicles. And this was industrial dynamite. Cut a long story short, my colleagues undertook some sampling of the dusts, and very shortly afterwards we found a suspect, and that was vanadium pentoxide. And any of you who know your process chemistry about Middle Eastern oils will know that some of the Middle Eastern oils are very high in vanadium, and when you burn them in the right oxygen concentrations, or the wrong oxygen, you can get vanadium pentoxide being deposited. And if you read your textbooks, you'll find vanadium pentoxide is associated, very well known, with green tongues and asthma, but there's no references anywhere in the literature to green testicles. And I was able to, again, through my industrial hygiene colleagues then at BP Kwinana, to say, have you had the same issues? And they said, yes, we had the same issues in 52, which is a long, long way. This is 82, 30 years before. But then the most interesting thing was, they said, and by the way, we've also found when we were investigating our issue in 1952, that there were reports in the German literature, published in German, in 1917, during the First War, when basically the German Navy had epidemics of asthma in their submariners because of high vanadium content in their diesel oils that they were burning in their subs. And so it's interesting. I mean, we think there's some of these new things, but this was known in 1917 because it was published in German. It was not known in the English-speaking world, rediscovered in 52, and rediscovered in 82. Now, we should have published this. We never did. We've talked about it at a couple of conferences. That was the story of the green testicles. How do we control this from an AIOH OCMed point of view? Well, first of all, we improved the quality of the clothing. We further improved the respiratory protection. But most importantly, there was a process change. And that was, prior to going in and cleaning out the refractory material, they switched for a week before 100% to gas, burned it out, and then went in. So we basically solved the problem at source. So that was my first and really exciting. The other thing at Alcoa, which was fantastic, was because the company was obscenely profitable. When I say obscenely profitable, I'm talking about being able to mine bauxite out of the Darling Ranges at $7 a tonne, and sell high-grade aircraft quality aluminum metal in the US, aluminum, not aluminium, aluminum metal, at $1,500 a pound, and nobody made any profit anywhere along the line. But it enabled me to do great things. And in particular, I went and visited Lübeck and Dragerwerk and met the 2 brothers who owned and controlled the company at that time, and did some amazing things. So I thank Alcoa for those opportunities. The second one I wanted to mention about some legendary hygienists who I've come in contact with was in relation to asbestos. And just recently I've had a lot to do with asbestos, both as the senior advisor to Comcare in relation to the Telstra NBN asbestos pits issues, and then more recently to do with the Mr Fluffy issues in Canberra, the loose fill asbestos. And in fact, for my involvement in that program, I was somewhat unkindly referred to as Dr Fluffy in Canberra. And in the recent days of various Mr Bubbles and clown children paedophile problems, being called Dr Fluffy is not a good term. So anyway, but one of the things that made me think particularly about Gersh was, not only my training back in 1982 when I did the master's program at Sydney Uni under David Ferguson in public health and major in OCMed, but Gersh was the senior lecturer there at the time, and Alan Rogers was there as well. But Gersh had a major role, and in fact he published a report in 1968 into the Mr. Fluffy loose fill asbestos issues, and basically said, this is going to be a big problem, you need to fix this now. And it was never acted on, and now finally, 1,000 houses demolished, hundreds of millions of dollars, and Gersh was right 40 years ago, or 50 years ago. But the thing I remember particularly about Gersh was he had a mission in life, and that was to educate the medicos. Because as you know, the industrial hygienists and the medicos have a sometimes fractious relationship. And one of the things that Gersh did, which no one else in his right mind would do, and certainly Alan Rogers didn't do, was Gersh would come in and give a lecture on asbestos. And he had this big container about the size of this, full of the bluest blue asbestos you've ever seen. And he'd open it up carefully, block his nose, put his hand in, and eat a mouthful. Eat a mouthful. He did it every year for the medicos, once a year. And as you know, he lived to his mid-90s, so it didn't affect his lungs. But his moral was, you know, so long as you don't breathe the stuff, it's safe. Now, I don't quite push that policy myself, but that was what I remember of Gersh. And of course, Alan's role was to put the balance in and bring this back to a common sense application of industrial hygiene and OCMed. Again, both Alan and Gersh were a fantastic influence on my career over the last 40 years. The other ones you might recall I mentioned were Vlad Vasak and Gary Gately, and this goes back to our common times at ICI Australia at Botany. And again, that was an occupational health heaven place for the professionals, but not necessarily the workers, because everything that was dangerous, dirty, explosive and toxic was made there. People used to ask me, is this a safe place to work? And that's a very loaded political question. And I used to say, well, probably the best way to answer that is, where do the senior managers live? None of them live south of the harbour. If you know Sydney, that was a long, long way away. But in particular, I mentioned we had mercury, lead, pesticides, vinyl chloride, explosives, whole stacks of things. But one of the particular issues that I remember to this day was in relation to the chlorine production plant that Botany had, where they had thousands of tonnes of mercury in the electrolysis of brine for the production of chlorine gas. And one of the things that the industrial hygienists and the chemists used to, well, first of all, as a medico, I used to do the urine mercury monitoring every month on all of these workers, and they were really quite high. They were within the limits, but way high. But Gary and others and the chemists used to do a mass balance every year of the mercury in the giant mercury anodes, not far, 30 metres from where my office was. And we used to lose about 7 tonne a year of mercury into the atmosphere. 7 tonnes. This is not parts per million. 7 tonnes would disappear just from the heat and the process losses. But one year the losses were substantially higher, up around 11 tonnes. And nobody could understand because nothing had changed. And Vlad and Gary and others were involved in doing these assessments. And in fact, nobody could understand it. The workers' exposures hadn't changed. Nothing was different. Until one day, the company had a policy because they'd had a lot of bicycle accidents on the plant. And one of the ways they controlled this was you could ride your bike to work, but you had to walk your bike everywhere, unless it was a tricycle, had to walk your bike everywhere in the plant. One day a fellow was leaving, a chemical plant operator was leaving, pushing his bike as he was supposed to do, and as he got to the front gate, his bicycle fell over and he could not pick it up. Something very strange. Anyone know what it was? He'd basically been flogging mercury and filling the frame of his bike with mercury and walking it out. And he was in fact the largest seller of mercury to the New South Wales state government for the Department of Education for their thermometers and... Yeah, so here's a bit of applied industrial hygiene. not only you've got to make good measurements, but you've got to watch your workers, and in particular, if their bicycles fall over, something's wrong. The other thing is we had a fantastic, some of you might recall the Dulux company, which in those days also had a red lead and white lead plant out in Cabarita in Sydney. And I did my MPH on lead, so I love lead. And I used to get bled every month. And my blood lead in the old units, micrograms per 100 mil, was always between 3 and 4 micrograms per 100 mil. The workers in that plant, there were two groups, production workers, maintenance workers. They ranged between 50 and 65. This is the geometric mean of those workers. Mine was 3 to 4. That just shows the exposure. But there was one fellow in that group who we found who was way outside the norms for his maintenance, and there was clearly something wrong. So again, we went and inspected this fellow, looked at his workplace, looked at his clothing, looked at his smoking, looked at his hand hygiene, looked at everything. It was still not right. There was something strange. Anyway, I called him in for a chat and said, I won't tell you his name, but Jim, if there's something wrong here, if we can't fix this, we're going to have to pull you out of work, out of lead work. And as you know, in those days, you got a very big bonus for being a lead worker. And that scared him. Anyway, about 2 weeks later, he came back and said, Doc, can I level with you? And my standard answer was yes, and I can keep it confidential so long as it's not anything that affects the health and safety of other people when I'm bound to, to talk to the management. And he said, there's none of this exposure from work, he says. I'm getting my exposure at home. I said, oh yeah, what do you do? He said, I'm the largest supplier of lead sinkers in the whole of New South Wales. Oh, how many centres do you eat? He said, I melt about 1.5 tons of lead a week at home. Where do you do that? I do it in my garage. And of course, here he had a fairly primitive furnace and melting and making lead sinkers. And I said, oh, gee, if this goes on, obviously that's where your exposure is. You're going to have to be pulled out of work. So I said, could I talk to the big boss? And he said, oh yeah, just so long as my job's not on the line. So I said, I'll promise you it won't be, but we'll see what we can do. So I went and talked to the big boss, who in those days was a big boss. I was probably earning 60 grand a year in those days, and this fellow was on 200 grand, which was just to put it in perspective. So I went and met him at Dulux head office. I said, look, this is the case. And he said, what do you think we should do? I said, well, if we could provide him with proper clothing and his respiratory protection and do all the washing of these clothes with the company wash, I think his levels will drop. It'll keep him happy, keep you happy, because the Department of Industrial Health won't be called in, and everything will be happy. So I said, all right, unofficially, we'll do it. We did it for him. He continued to be the biggest supplier of lead sinkers in Sydney, and over the next 6 months, his blood lead levels came back to virtually the same as everyone else who was in the maintenance team. Now, this is a bit of atypical. This is not what the textbooks say, how you'd address the problem, but it worked very, very well. And again, I mention that because Vlad in particular, Vlad Vasak, ran the most beautiful reference laboratory for the testing of blood leads. As you know, blood lead testing is a real art, or certainly was then, 30 years ago, and they were gold standard, whereas the New South Wales Government Reference Lab was plus or minus 30%, 3-0 in those days. And the ICI figures were beautiful, and so that's why I know they were accurate. We also had in ICI a pesticides plant out at Villawood, and I used to go and do weekly cholinesterase monitoring of all the workers there because they were quite heavily exposed at times to a variety of pesticides. But a very interesting applied industrial hygiene solution was, how do you keep a track of what people are doing and what they're spilling out of hours, e.g. weekends? And the then plant manager, a fellow called Alan Hardman, came up, Gary may remember, came up with a brilliant but somewhat illegal solution. And that was that he arranged unofficially for the drainage channels and the drains from the floor of the chemical manufacturing plant to be rerouted and to pass through a goldfish pond and then into the trade waste. And the first thing he'd do on a Monday morning is he'd go straight to the goldfish to see were the goldfish alive and well, and that way he could keep a check on what had been happening in real time over the weekend when none of the senior managers were there. So a very nice piece of a place. So I've picked up and learned an awful lot of things. We won't talk about vinyl chloride monitor or explosives, but if we have time at the end, I might just come back to an issue in the Nobel division, a very interesting case where we had an occupational asthma, which had been not known had been forgotten for 300 years, but was in the old literature in relation to workers who used guar, who made guar gums from the guar plant in India 300 years ago, and now it surfaced in guar, which, as you may know, is a food additive and used as a thickening agent, not only in explosives, but a whole range of jams and other stuff, and can cause asthma. But we'll come back to that. The other one I wanted to mention was when I was up in Japan for many years, in OCMed, but I had responsibility for health, safety, environment and medical, and we had a phenomenal two industrial hygienists, but one was this man called Chris Norden from the US. And IBM Japan is a phenomenally successful company. At that time, it had about 23,000 workers and generated 1/4 of IBM Corporation's net profit globally. Very big. And to cut a long story short, they had 3 plants in Japan, 2 where they manufactured semiconductor chips, which were used not only in IBM, but also in Toshiba and a whole range of other companies, all manufactured by IBM. One of the things in clean rooms and in the manufacture of semiconductor chips is the use of silane. And basically, as you may know, silane wants to mix with oxygen and catastrophically detonate and form sand. That's basically complex chemistry made simple. And the interesting thing about silane is that you can actually cause it to explode or to detonate without any external flames, without any electrical sources. Just even shaking or moving it can be enough to trigger a catastrophic explosion. And our industrial hygienist, Chris Norden, in part of his research, had uncovered some work coming out of Europe, out of British Air Liquide and VOC at the time, that said, this is even more dangerous than we thought. The US company implemented some controls which included putting their silane storage hundreds of meters away from the plant so that if it went bang, there would be no problems. But of course in Japan, this was not possible because the plants were in the middle of industrial areas. There was a school right next door, there was a hospital, and also the Japan law basically said you cannot have things that go bang out in the open. You can't put them in underground bunkers. There were all kinds of restrictions. And to make things even more difficult, the Japan High Pressure Gas Association, which was a trade group in Japan, basically said, we don't think this is a problem. And and I lived in Japan and worked in Japan for many years, and as you may know, if a trade association says this is not a problem, then Japanese industry will say this is not a problem. They did not like this advice from our US industrial hygienists. But eventually, we wore the plant manager down. The plant manager in particular was the one down at Yasu, which is down near Lake Biwa in southern Japan, not far from Kyoto. And eventually, when he was convinced, and again, the other thing, as you may know from a Japanese perspective, once a Japanese company decides to do something, heaven and earth moves. It may take a long time, but boom. So once this plant manager was convinced, he arranged just over 40 engineers, design engineers, to go onto this project and come up with a very good way to manage this potentially explosive gas, which involved, because they couldn't set it outside, they ended up building a special blast relief bunker on the roof of the plant. So with blast doors, so if it went bang, it went up and the stuff went up to the sky instead of going out. They didn't want to do it. It cost tens of millions of dollars. And they put 40 engineers onto it, but they did it beautifully, grudgingly. 6 weeks after it was finished, a big competitor company, Hitachi, who also had a beautiful manufacturing system just on the outskirts of Tokyo, had a catastrophic explosion in their plant due to silane. And not only did it kill a few people, but it also put their plant out of production for 6 months. Now you might say, well, it's only a bang. But of course, if you have a clean room contaminated with sand, fine sand, you can imagine this was a crippling injury. And so suddenly our industrial hygiene gurus went from being absolute villains to heroes. and in fact our industrial hygienist and myself were awarded an IBM Japan Management Excellence Award for that program. So it was we saved a lot of lives, we incurred a lot of cost, we breached and then the Japan High Pressure Gas Association said, all right, we accept your evidence, we were wrong, and they changed their rules. So that was very good after the event. And now coming to my defence times, and in particular beryllium, and I mentioned Wally Mazurek from what was Defence Science and Technology Organisation, and although much of this predates Martin's time in defence, he'd been involved in the subsequent things. This was an issue to do with the historical use in the 1970s of needles in air-powered derusting, descaling guns. 2% beryllium, 98% copper, where you needed non-sparking, for example, in fuel tanks on aircraft carriers or fleet oilers or the like. And in particular, they used a thing called Jason's pistol. Anyone know what Jason's stands for? It's a trivia quiz for hygienists. Jason's actually stands for Johnson and Sons. So there's no apostrophe in it. It's not Jason apostrophe S or Johnson and Sons. And Johnson was an Air Vice Marshal, Battle of Britain Air Ace in World War II. After the war, he bought the rights to this and developed and sold globally this air-powered rattle gun using the variety of needles. Subsequently, Trelawney has taken that over, and now it's a Trelawney/Jason's pistol. One of the things, and this is a medical fault, there was a problem identified, not by an industrial hygienist, but by the bosun on the ship back in the HMAS Supply in 1970, who came to the MO one day and said, "Doc, we've got these new needles, and they contain beryllium." The doctor looked up his textbook on beryllium and said, "Holy Christ, this is a seriously dangerous thing." Now, of course, as you know, in those days, beryllium metal is a very dangerous thing. 2% beryllium, 98% copper is not. But he didn't know that. And on his own volition, he made up a chart, a big red stamp about 6 inches by 4 inches, and stamped it in every sailor's chart that said, "This is to certify that sailor XYZ has been exposed to toxic beryllium dust, HMAS Supply, September through December 1970, signed medical officer." That medical officer is now one of the most senior radiologists in the country, and his name is deeply suppressed. More secret than some of the top secret things. But that's what happened. And then 20 years later, this was discovered when this sailor put in a claim to DVA, my current employer, Veterans Affairs. And in that process, he said, "Oh, here's the medical docs that we've looked for in your claim. And by the way, he found for the first time this evidence of this old thing." And of course the question was, why wasn't I told? Why didn't you let me know? What have you done? How have you controlled it? Navy went to ground, didn't come up with all the truth, and then the press got onto it. And Daily Telegraph in Sydney ran over the next 6 months 30 articles and 3 editorials just on this issue. And basically they said that 6,000 sailors have been exposed to toxic beryllium dust and 6% of them will die. Now, that was not true, but that was the claim. But from an IH perspective, I went to the program in the US through the Duke University forum, OEM forum at the time, and there was, and I posed this question about beryllium, and a Canadian industrial hygienist specialist who had retired said, "Oh, I did some work on this 30 years ago." And he actually said, "I might have a copy at home." And he sent me, at no cost, a big 200-page document that he'd done, which was fantastic. DSTO found 9 of the original needles and recreated a beautiful test rig to show and to recreate using today's technology to measure all the exposures which weren't able to be measured 30 years ago, but were able to be measured now. I probably haven't got any time to go on to this, but for another time, I have some wonderful slides that will show that. So look, what I've tried to do today is just give you a potpourri of some multiple short cases, show how over my 40 years of working life in OCMed, Hygiene and OCMed have been able to work together, produce really good things, and I'd just like to pay tribute to those 8 specialists, industrial hygienists, who I really do thank for the fantastic learning that they've given to me, and I've been able to work with them, and I've learned so much from them. So Julia, thank you very much, and I'll escape while I can.